Here we're going to show you guys how to do inverses and determinants on our matrix, or on a matrix on our calculator. So let's do number 1 and 2 together. So for number 1, I'm going to start by entering this matrix into my calculator. So I'm going to press second, and then the matrix button, which is 3 down. I'm going to go over to the Edit tab and select one of these matrices. Now I have a bunch of stuff in here already. I'm just going to reuse one of these and just type over top of things. So A is a 2 by 2, so I can just press enter there. And then I'll change my matrix so its entries are 2, -1, -6, +1. I've done that. So I can just type in the number and press enter and move to the next spot and just type over whatever else was there already. Once you've done that, exit out to the main screen by pressing second and the mode button. So again, we're just typing in this information into matrix A. So to do the inverse, what I'm going to do is I'm going to press second and the matrix button. I'm going to select matrix A by pressing enter, and then press the x to the -1 button, which is the same button as the matrix button without pressing second beforehand, and then just press enter. Notice here that the calculator has given me an answer as a decimal. The answer that I wrote was fractions. If you want this matrix as a fraction, you can do the following. If you press the math button and then select the frac command and then press enter, your calculator will write your answer as fractions rather than decimals, which is pretty nice. Everybody feel okay there? Let's do number 2. In number 2, we're going to be taking a determinant. Yes, Andrew? I pressed the math button, and then I just chose the fraction command and pressed enter. So let's do number 2. Number 2, we're taking a determinant. We're going to start this the same way, so we're just going to go to that matrix menu. We're going to go to the Edit tab. This time I'm going to select matrix B. B is a 2 by 2. And I'm going to update my entries so that they're 2, 6, -6, and 4. Once I've updated those values, I'm going to exit out by pressing second and the mode button. And now to retrieve the determinant command, I'm going to press second and then the matrix button. And this time I'm going to move over to the math tab. Notice that DET is the first command under the math tab. So I'll select the determinant. And then what am I going to take the determinant of? Well, I want to use matrix B. So I'll go back to my matrix menu. Select matrix B, press enter, close my parentheses, and run that, and here I get 44. Why don't you guys take a moment on your own here with your graphing calculator and try to do 3 and 5 on your own on your graphing calculator. So 3 and 5. Why are we skipping 4? Yeah, you can't do it, right? So that's not going to be real informative. We'd like to see stuff that works out. So we'll look at 3 and 5. And as you're doing that, just to point out to you guys, then obviously you can see that I've written up the solutions to this as well. You should kind of, while we're doing these things, make sure you kind of check your own work. And if there's questions on things, I'd be happy to go through and do an example or two here when we finish, okay? But right now, you guys are trying to do 3 and 5 on your calculator. How do we do? Do we get these to come out on the calculator? Anybody having calculator issues that we need to deal with? No, we're okay? All right. How about any of these questions that we had? Is there anything we'd like to go over here as a group? Okay, fair enough. So, remember what is the focus of this? What was the focus of this chapter? It was about solving systems, right? So I had promised when we started talking about matrices here that this would eventually circle back and we would use these matrices to solve a system. So what we're going to do today is we're going to use or show you how we can use a matrix to solve a system of equations. say we have this system, negative x minus 5y minus 5z equals 2. 4x minus 5y plus 4z equals 19. And then x plus 5y minus z equals negative 20. What I want to do right now is I have 3 equations, right, with 3 variables. What I want to do is translate this into a single matrix equation with a single matrix variable. So how do I do that? Well, I want it to turn into something like ax or a times x is equal to b, where a, x, and b are matrices. That's my goal, is to get something that looks like this. Everybody okay with that idea? Now, if I get something that looks like this, what I can do to solve for that matrix variable x is I can multiply on the left to both sides A inverse, because I know that A inverse times A is going to give me what? That's just the identity, right? By definition. And I know that anything times the identity remains the same. So if I'm able to translate my system above into a matrix equation like that, I can solve a matrix equation by doing that following process we just described there. Andrew? X plus 5y minus z equals negative 20. That's what you needed? Yeah. Okay. Yeah, no problem. Okay. So our issue here is doing the question mark. If we're able to translate that system of 3 equations into a matrix equation, it seems like we have the tools needed to be able to handle that, right? Okay. So, what are we going to do then? Here's how we do this. My matrix A is going to be what's called a coefficients matrix. Where did I get these numbers from in my matrix A? They are literally the coefficients from my system, right? Okay, well that's really easy. So notice that because my system was a 3-variable, 3-equation system, my coefficients matrix is going to be a 3 by 3. So I know my matrix X is going to be a 3 by something, right? What are the variables we need to solve for in this problem? X, Y, and Z. Well, that's 3 things, right? So what I'm going to have is just the 3 by 1 matrix, X, Y, and Z. And that needs to answer or I need that product to equal the solutions matrix 2, 19, 3, or 30. Annalise. 0. Observe that when I multiply matrix A and matrix X together, I get a 3 by 1, which I know, at least from a dimension standpoint, matches up being equal to this matrix B, which is also a 3 by 1. Does everybody feel okay with how I've gone and translated that system of equations into a matrix equation? If you're not yet convinced that this is really the same thing, let's just, for the sake of argument, multiply these two things together. This is not a necessary part to solving the matrix, but if you don't see why that system of equations can be broken into a matrix this way, if we actually do this multiplication, it'll become really obvious what's going on. So to multiply these, I'm going to multiply row 1 by column 1. When I do that, I get negative 1 times x, negative 5 times y, and negative 5 times z. And then I'll do row 2 times column 1, since there's only one column in matrix X. It's going to give me 4 times x, minus 5 times y, plus 4 times z. And then row 3 times column 1, so that's x plus 5y minus z. So this is literally matrix A times x. What do you notice about this? It's literally that side of the system, right? Oh, okay, sure. So A times x, if I build out my A and x this way, is going to be exactly the same thing as this system. Is everybody convinced of this now? Okay. So let's say I want to solve this system. Well, based on what I did below, xyz is going to be equal to that. And how can we calculate this? I'm just going to use my calculator. Whoa! So I'm going to use matrix A, which is going to be this 3 by 3. And then my matrix B is going to be this 3 by 1. So what I need to do then is just to do A inverse times B. type in all that right? Just double check here real quick. Okay. That wasn't the answer I was supposed to get, so I'm just double checking that I typed things in correctly. Ah, okay. So this is fine. I just wrote down my initial problem wrong. That's fair. Yeah. So notice here, this is negative 20. For whatever reason, I wrote a 30 here. I don't know. I'm going to chalk it up to being Friday. So I'm going to change that so it all matches. You ever make a mistake? Happened to me. Okay. Try that one more time. There we go. So that gives me this. What is that going to tell me then? It tells me x is negative 2, y is negative 3, and z is positive 3. So my solution is exactly that. Grace, is that a hand, or you just kind of... No, you're good? Okay. You guys ready to try one on your own? Okay. So I'm going to write out a system here and let you guys try this one with your graphing calculator. So take a moment, try to do this one, just do it in your notebooks or whatever is fine. And then we'll go through this as a group here in a moment. Oops. What do you think? If you guys need another minute or two? Okay, that's fine. Okay. So, first thing I'll do is translate this into a matrix. Here's my matrix equation. Everybody okay with that? So the solution to this then is going to be A inverse times B. And then from here, I'm just going to use my calculator to perform that matrix operation. So I think that this is like a lovely test kind of level question. On the test, what I've written down would constitute as work for this problem. The kind of direction that I would write for something like this would be like, solve this system using a matrix. Use your calculator to perform the matrix operations. Something like that. So the work that I'd be interested from you guys would be writing down what your matrix equation is, and then what the solved version of your matrix equation looks like, basically what you're going to type into your calculator. And then after that, I don't need to see anything else. You can just type in everything to your calculator and spit out your answers. Does that seem fair to you guys? The reason that we'll do that on the test is that I know it takes a long time to solve like a 3-variable system, right? I can only ask you to do that by hand like once during a test setting. So this allows me to ask other 3-variable questions in a way that's not going to be really time-consuming. You just got to be able to write down what you're putting into your calculator, and then type in your calculator. Is everybody okay with that? So, there's an obvious question now kind of waiting for us. Was every system of equations solvable? Was every system of equations uniquely solvable? Like, were we guaranteed to get one answer? No, right? You could get no solution, or you could get infinitely many solutions. So, those situations, this method of using a matrix equation kind of falls apart. Because what's going to happen is that we're going to end up getting a like the inverse matrix is not going to be defined. So we need to do another method. We can make this a little bit better. So this method that we just got done talking about, this was like using a matrix equation. This is like method 1 of using a matrix or using matrices to solve one of these. Method 2 is called Gaussian Elimination. And this one is even better. Yes, Elena? Sure. So the idea here is using elimination. So the idea of Gaussian elimination is the elimination that we learned before. So what we're going to do is we're going to take a system of equations. Oops. I want that to be negative 14. And we're going to turn this into a single matrix. Everybody's okay with how I wrote that single matrix? It shouldn't be a surprise, right? Leslie? Oh, yeah, that should be a 4, definitely. Thank you, Leslie. Right, I've just taken everything from the same spot in the system and put it in the same corresponding spot in the matrix, right? So I have like my x coefficients, my y coefficients, my z coefficients, and then my solutions all line up vertically just like they would for elimination. And now I'm going to do this Gaussian elimination. And what I'm going to get is the 3 by 3 part of my matrix is going to look like the identity. And the last column is going to be some numbers. So if I interpret this now, if I rewrite this back as a system, if I look at the first row of my matrix, what's that saying? It's saying that 1x plus 0y plus 0z is equal to 2. The next row, what that says is that 0x plus 1y plus 0z is equal to 1. And then the last row says 0x plus 0y plus 1z is equal to negative 3. Everybody okay with how I've interpreted that matrix into that system? Everybody good? Leslie? Oh, so this is, the calculator is going to do that part for us. We haven't discussed how the calculator is going to do that, but that's what the calculator is going to do. And then from here, if I take this first equation, what does this really simplify down to? Just x equals 2, right? 1 times x is x. 0 times y is 0. 0 times z is 0. X plus 0 is just x. So we're just left with that. Similarly, I get then the second equation tells me that y is 1. And the third equation tells me z is negative 3. Everybody okay with that idea? Yes. Sure. So let's show you how to do this Gaussian elimination on our calculator. So I'm going to start by writing this matrix. One button. So I'll go into my matrix menu. I'm going to use matrix C, I guess. This matrix has 3 rows and 4 columns, so I'll make a 3 by 4. So once I have that matrix typed in, I'm going to press second and the mode button to exit back to the main screen. And then I'm going to go press second and the matrix button again. I'm going to go to the math tab there in the middle. And I'm going to scroll down all the way. And the command I'm looking for is called RREF. So in my calculator, that's Command B. And I'm going to do RREF on that matrix C that I just made. And you'll see that the calculator did indeed do kind of what I had promised it was going to do. Now, the nice thing about using the Gaussian elimination is it allows us still to solve systems that might have no solution or infinitely many solutions, as we can still handle those situations. So let's look at an example of that. Is everybody okay with what we did here on the calculator? So let's look at, this is a no solution problem. So I'm going to start this exactly the same way. So I'm going to go press second and the matrix button. Go to the Edit tab. I'm going to do this into matrix D. So again, this is a 3 by 4. So 1, 1, 1, 3, 4, 4, 4, 7, 3, -1, 2, 5. And then I'll exit back out to the main screen. Go back to my matrix menu. Go over to the Math tab. Retrieve the command RREF. And do that on my matrix D that I just made. So let's see. I turn this into a system. I then did the RREF, or the Gaussian Elimination. That's going to give me this matrix here. Which of these rows tells me that this is no solution? Which row tells me that there's no solution? Row 3. That's correct. What is row 3 saying? It says 0x plus 0y plus 0z is equal to 1. When I simplify that down, that says that 0 is equal to 1. That tells me no solution. Is everybody okay with that idea? Okay. Look at how fast we're able to do these using the calculator, though, right? How long did it take to solve one of these systems by hand? It's pretty nice, right? So now let's look at this system. This is an infinitely many solution situation. Yes. Sure. So we'll do the same thing. We're going to rewrite this as a matrix. We're going to do that Gaussian elimination. And let's see what we get. So I'm going to do mine in spot E. Again, now I'm going to do the RREF on that matrix E that I just made. So which of these rows tells me that I have infinitely many solutions? row 3. What row 3 is saying is it says 0x plus 0y plus 0z is equal to 0, or just rather 0 equals 0. Everybody okay with that? But remember, when we wrote these infinitely many solution, or we had these infinitely many solution situations, we wanted to write the generic answer to this as well. So the way to describe those infinitely many solutions. The answer that we have here from the calculator will also allow us to do this. Let's look at what else we have here. What is this row telling us? Well, it says 0x plus 0y plus 1z equals 0, or just that z equals 0. So I can say that. And what does the first row tell us? Well, it tells me that 1x plus 1y plus 0z is equal to 4. Or rather, x plus y is equal to 4. So if I solve that in terms of either x or y, let's say I get the x by itself, to say that x is then equal to 4 minus y, by just subtracting y from both sides. Well, I can write the x answer as 4 minus y. And since the x is in terms of y is like the independent variable. And there's my generic solution, or my general solution for my infinitely many. Okay with that one? Okay. Let's stop here.